Hello everyone. In this video, we are going to see how to visualize Signum function in MATLAB platform. The Signum functions usually used in communication and control system to indicate the direction of a signal or direction of an object. So the Signum function can be represented in both continuous time signal as well as discrete time signal. So as you see here, in a continuous time frame, whenever t less than 0, the magnitude of signum function will be always -1, which is the indication of the object or signal is going in backward. And whenever t equal to 0, the magnitude of signal is 0, which is indication of the signal is in standstill condition or the object is in standstill condition. Similarly, whenever t greater than 0, the magnitude of signum function will be always equal to 1, which is the indication of the object or signal is going forward. Similarly, in a discrete time frame, whenever n less than 0, the signal is always -1. Whenever n equal to 0, the signal is always 0. Whenever n greater than 0, the signal is always equal to 1, which is indication of backward, standstill, and forward respectively. Now we will see how we can visualize this signal in both in continuous form as well as discrete form in MATLAB. So first, when you are starting a MATLAB command, so it is always suggested to start with the CLC command, which is used to clear the previous results which are displayed in the command window, and followed by we'll be typing the command called clear all, which is used to clear all the variables which are created on the workspace. Now to indicate the Signum function, that is to plot the Signum function in MATLAB, I need to create a two variable. One is x-axis variable, the other one is a y-axis variable. So in our case, x-axis variable is all about time frame as far as continuous time signal is concerned, and similarly for a discrete, I have to create a discrete samples for a x-axis, and corresponding to that I also need to create a y-axis. Then I need to call for a plot signal to visualize the signal function, right? So first I am going to create x-axis signal, that is time for a continuous time, and samples for the discrete time. So let's create first a time. So let us take the limit for the time frame from -10 to +10. So I'm going to create a time signal as t equal to -10. So this is actually a starting point. Then from there I'm going to increase this step by 0.001, and then I'm going to increase up to 10. So this function will create a time frame of starting from -10, and each step it will be incremented by 0.001 and it goes up to 10. So this is actually for continuous time. And similarly I'm going to create for now discrete. For discrete, the signal must be a discrete values like 0, 1, 2, 3, and so on. So I'm just going to take that variable name as n equal to, so I'm going to consider the starting point as 10, and each step I want to increment by 1, because in a discrete time the signal is present only at a discrete time. So let's take 1, then actually starting point is -10, right? 1, and then the ending point is 10. Okay, so this is for discrete time. Okay, right? So now we have created a x-axis data. Now I need to go for creating the corresponding magnitude based on the Signum function. Okay, so now I just name the figure first. So let's keep figure is a MATLAB command used to name the figure, and I'm going to give a title for this. Okay, so the title for the figure, let's say we are going to create a Signum function, right? Right. Okay, and I wish to see the both discrete as well as continuous time representation of signal function on a single plot. So for that, I am going with the command called subplot, okay, which is generally used to plot multiple graphs in a single plot. Okay, so I want to see the signal one after another. So which means I'm going to keep two rows, which means first row and then second row. Then I'm going to keep one column. Then I just want to keep first continuous time signal of a signum function on the first place. So for that I'm creating 2 comma 1 comma 1. Okay, right? So now I have to go for plotting the signal. So before I create a plot signal, now I need to define the magnitude based on the signum function operation, right? And we know that the signum function is equal to -1 when t less than 0, and equal to 0 when t equal to 0, and when t greater than 0, the signal must be equal to 1. So I have to create this mathematically here. So for that, I just create the magnitude of signum function, like signum of let's say amplitude. Okay, this is a variable name I'm just creating. So now I want to keep the entire signal, that is the magnitude of entire signum signals, initially 0, and then I just declare as per the condition, the magnitude I'm going to declare as per the condition, right? So we have a time t over here. Now for each time I need to define the signal magnitude. Am I right? So first, initially I'm going to keep everything as 0. Okay, so zeros of, and which I'm going to create with the whole size of t. So size of t will give the size of the entire t matrix. Let's say we have created from -10 to +10 with the steps of 0.001. So including 0, this will create nearly 20,001 data. Okay, so it is actually going to be a row vector, right? 1 cross 20,001, right? Now for all the time step, I'm just declaring the signum magnitude as 0 now. So now I just going for putting a conditions. As per the signum function, when t less than 0, the signum function must be equal to -1. Okay, so let's do that first. So whenever signum amplitude, okay, less than 0, I'm just indexing it now. So t less than 0, right? So this is like this t less than 0 is an indication of an index, right? Whenever t less than 0, then the signal must be equal to -1, right? Similarly, whenever t greater than 0, the signal must be equal to +1. Similarly, when t equal to 0, the signal must be equal to 1, which we already done actually. We already made all the, signal for each time step as 0. So already at 0th position, the signal is already 0. So there is no need to declare it again, right? So now we go for plot. So I'm just calling plot. First, I'm calling time axis, that is x-axis, and then signal amplitude, right? And now I just give a labels for x-axis and the y-axis. So let's keep x label. So x label is about time, and then y label is about amplitude, right? Then just I make a title for this plot as signum function in continuous time. Okay, right? So now the same we try to do it on a discrete time now. So now I am going to create a space for putting a signum function in a discrete form. So I go with the subplot again. Now we have a two row on the first column. I want to keep that plot in the second place. So always first number indication of row, second number indication of the column, and third number indication of the place where you are going to put the plot, right? So which I'm putting 2 comma 1 comma 2, right? Now again I have to create a signal magnitude as per the function, right? So let's create now signal amplitude, which we already used, so maybe we'll use the other name as, right, signal amplitude in discrete time, right? So let's create again for each of the instant. I'm going to keep this as 0 initially for each of the n. Okay, then as per the function, whenever n less than 0, the signal must be equal to -1. Similarly, whenever signal greater than or equal to 0, that is sample greater than or equal to 0, the signal must be equal to +1. And also when n equal to 0, the signal must be equal to 0, which is no need to do because we already declared all the signal as 0, and I just replace again when n less than 0 the signal is -1, and when n greater than 0 the signal is +1. Okay, so already at n equal to 0 the signal is in 0 position, right? Now I am going to plot. So in MATLAB, to plot the discrete signal we should use a command called stem. So if you want to plot a normal 2D plot, you go with the plot function, whereas if you want to plot a discrete signal, you go with the function called stem. So I'm going to call stem of my x-axis data samples n comma my amplitude, signal amplitude, signal sign ampli, right? Okay, now I just label the data. So x label, again this is amplitude, and let's create y label. uh, Sorry, x label is about sample, right? Let's have a sample, and y label is about amplitude, right? And let's keep a title as signum function and discrete. That's it. Now let's save this file. So let's keep, this is signum function. Okay, let's run this. Okay, we have here, I'll check it out. Oh, this has to be name actually, right? Now run this. Okay, there is another one function. Let's fix this. Actually I made a wrong spelling over here, right? Now run it again. Yeah, now you can see this is actually a signum function continuous time frame, and this is a signum function at discrete time frame. I hope now you understood how you can visualize the signum function in MATLAB. Thank you.